Hello guys, good evening everyone. So welcome to today's live session. So first introducing myself, I'm Sumit Nahak, currently pursuing MBBS in AIIMS Bhubaneswar. I had secured All India rank 691 in 2021 and currently teaching you physics. Okay, so guys, I have selected a few questions which you had doubts on. In this 1 hour session, I will at least try to cover up 15 to 20 questions which you had doubts on. So, okay, let's start the session. Okay, broadly, I'll try to cover the theoretical aspect, and I have taken few of some numericals also. So please focus here. Okay. So on the left side of my screen, I have taken the questions, and on the right side, I'll try to explain you it in a very simplified way. Okay. So let's start the session. So starting our for the first question is, what is elastic collision? So okay, learning about collisions. So from the word itself, collision means what? From the word itself, जब आप ये वर्ड सुनते हो कि collision से आपको दिमाग में आता है क्या है कि two objects are colliding मतलब टकराना, two objects दोनों में टकरा रहे हैं. ओके, सो collision का वही बेसिक डेफिनेशन वही है. collision का मतलब क्या? two objects एक दूसरे से टकराना, वही होता है इसका बेसिक डेफिनेशन. सो collision का टाइप है फिर, one is elastic and another one is inelastic. So how will you differentiate between these two, elastic and an inelastic collision? How will you differentiate? So first I will explain you about elastic collision. What is an elastic collision? Okay. So what is an elastic? An elastic collision means if these are two objects, मान लो या फिर कोई vehicle मान लो, if these are two objects or vehicles which are moving, if this bike is moving at a velocity of v1 and this bike is moving with a velocity of v2, अगर इसका velocity object 2 का velocity object 1 के velocity से अगर ज्यादा है, object 2 का velocity अगर object 1 के velocity से ज्यादा है, तो होगा क्या? जब ये आगे आगे मूव होते होते जाएगा, ये इससे टकराएगा. ओके, टकराना मतलब collide. Object 2 will collide with object 1. So elastic collision means, how will you define an elastic collision? When I'll write and then explain you. When two objects collide with each other, and move separately after the collision, Do you understand this? मैंने एक बार collision हो गया, ये था before collision का फोटो, before collision, and even after collision, this is object 2, this is moving with a velocity of v final 2, this is moving with a velocity of v final 1, but separately. They're moving separately. This is what is elastic collision. Okay. Okay. So I'll explain about the momentum and the kinetic energy part after I explain elastic collision. So bear with me. Okay. So this is elastic collision. माने before collision भी separately move कर रहे थे, after collision भी separately move कर रहे हैं. That's the thing that you need to take off. Then inelastic collision. Inelastic collision में क्या होता है? When two objects collide and move as a single mass, after the collision. Do you get me, guys? देखो, ये same to examples लेते हैं. Object 2 था, ये object 1 था, ये था before collision का photo. And after the collision, what is happening is these two objects are joining together and moving as a single mass. This is inelastic collision. Okay, so this is the basic difference between elastic and an inelastic collision. Elastic माने दोनों separately move होंगे, inelastic माने दोनों मिलके move होंगे. तो I'll discuss about the kinetic energy part and conservation momentum. So what is happening to the momentum here before collision and after collision? You know this very clearly that until and unless an external force is applied on an object, until and unless an external force is applied on an object, its momentum will be conserved. Okay. So here no external force has been applied. Has it? Is there any external force here, guys? No. So here no external force has been applied. So momentum will be conserved. Momentum will be conserved. Okay. So initial momentum will be same as final momentum. Okay. And what is happening to the kinetic energy, guys? What is happening to the kinetic energy? So in the first case, elastic collision, it's a perfect and it's a perfect collision. Here, no energy loss is there. All the kinetic energy is being converted into the is just being converted into kinetic energy. It's no energy is being converted to any other forms of energy. Okay. So in elastic collision, remember this here, this is important. In elastic collision, kinetic energy initial is same as kinetic energy final. Okay. But in inelastic collision, some of the energy is being lost. No, it's not lost, but some of the energy is being converted to other forms of energy. What I mean to say is, some of the energy, like here when the collision is taking place, some of the energy is being transformed into sound energy. You must have seen some accidents, guys. When the accidents are happening, when the two bikes or two cars are colliding with each other, some of their kinetic energy will be converted to sound energy. Some of them will be converted to light energy, little spark you'll see. Okay. So some of the energy is being converted to other forms of energy. That is why kinetic energy initial is not equal to kinetic energy final in case of inelastic collision. Do you get me, guys? Okay. So initial will be more than final. Okay. Because some of the energy is being converted to sound energy, light energy, some other forms of energy, not into kinetic energy only. Okay. So this is the main thing, guys. Elastic and inelastic collision. This is all you need to know. Okay. If you have clear concept of this, then you can at least solve numericals and even write the theory part in your board exams, class 11. Okay, class 11 annual exams. Okay. So moving on to the next question, question number 3. What is a scalar quantity and what is a vector quantity? Okay, this I have explained to you so many multiple times. Again, okay, what is scalar and what is vector? Okay, so first I will give you a definition, then I will go for examples. Okay, so what is a scalar quantity? The physical quantity which has only magnitude. It doesn't have any direction. Okay, direction is not defined for these physical quantities. Okay, so how will you define scalar quantity? The physical quantities, which have only magnitude, no direction. Okay, those are called as scalar quantities. And what do you mean by a vector quantity? Vector quantity means the physical quantities which have both magnitude and direction. Okay, so when I give you an example, you'll clearly understand this. So if I am saying, for example, your name is Rohan, Rohan is moving with a speed of 5 meter per second. Okay, and here I'm not mentioning anything about his direction, like where is he going, in which direction is he going. I'm not mentioning anything. The only thing I'm saying is Rohan is moving at a speed of 5 meter per second. That is speed. That is speed. Means I'm saying only it has number, magnitude. Then when I'm saying Rohan is moving at a speed of 5 meter per second towards his girlfriend or whatever it is, moving towards someone, when I'm specifying the direction. Do you get me? I'm specifying the direction. So the next quantity which I told in the second part is defined as velocity. That is not speed. That is velocity. Why is it velocity? Because I'm giving you the number, the magnitude as well as the direction. Okay. So that is why scalar quantity here, the scalar quantity will be speed and vector quantity will be velocity. Okay, velocity means when I told Rohan is moving with 5 meter per second towards his girlfriend, that is velocity. And when I told Rohan is moving with a speed of 5 meter per second, that is speed. It doesn't have any direction. So what are the other scalar quantities do you know of? Distance, you know, distance is another scalar quantity. Vector may you can write displacement. What are the other quantities you know of? Scalar quantity, you can write work. Is a scalar quantity. It doesn't have any direction. Then vector quantity, what you can write? Force is a vector quantity. Displacement is a vector quantity. Velocity is a vector quantity. There are so many examples of scalar. Electric field is a vector quantity. Magnetic field is a vector quantity. You will study about all this when you study further in class 11 and the class 12 for the chapters. You'll read about so many quantities and you can classify them in any of this scalar vector quantity. You can put those quantities here in scalar or vector quantity. Okay, it's not very difficult thing. Okay, guys. So I think this is all about scalar and vector quantity. I'll move to our next topic for today. What do you mean by motion? What do you mean by motion? So motion. I need to explain you guys about motion. I don't think any of you would be having too much doubt about this topic. Motion is a very simple thing. I mean, see, when you are moving, when you are doing your normal jobs, day-to-day activities, what are you doing? You have to move from a point to another point. If you want to go to your school, if you want to go to your college, what are you doing specifically? You're going from one point A to another point B. So in the language of physics, what are you doing actually? You are doing is motion. You are doing a motion. You are moving from one place to another. That is what is motion. Okay. So motion and opposite of motion will be rest. Rest means when you are not moving, when you are simply sitting. Simply sitting. That is rest. But if you will see in a broader perspective, I mean, earth is also moving with you. So you are never in a rest. You can think like that, but to understand physics, you have to you have to understand the point of view. Where are you observing from? You're observing from earth itself. Okay. So from earth, from the point of view of a person on the surface of earth, you are moving or not. That is motion. Okay. The motion is very simple. So you know what is motion. I need not explain it furthermore. I'll just give you an idea of the physical quantities involved in motion and what are the three equations of motion we use in physics. Okay. So okay, u is initial velocity. The speed you had when you started your motion, that is u, that is initial velocity. The speed you had when you reach your destination, when you reach the point where you wanted to, that is your final velocity. Okay, then then comes the term A. A is acceleration. I don't think anyone will have a doubt about acceleration. Acceleration is the amount of velocity you are increasing per second. That is acceleration. Then comes T. T is time. S is displacement. So taking this taking this 5 physical quantities, we have defined, we have 3 equations of motion. So these 3 equations of motion should be crystal clear to you and should be at your fingertips. Okay, I think you must have read all this in your class 9, but I'm just revising it for you. 3 equations of motion. So the first equation of motion is V is equal to U plus AT. This is equation number 1. Equation number 2 is S is equal to UT plus half AT square. Equation number 2. Equation number 3 is V square minus U square is equal to 2AS. Okay, guys? So these are the 3 equations of motion. So why do we learn these equations? Because you will find various numericals where 3 quantities of this will be given and you need to find the other quantity. When can you find these quantities? When you will be remembering these equations. Okay, three quantities will be given and they will be asking you about the another quantity. Okay, that is where these equations are used. Okay, so I think it's clear for you, and you can learn the derivations of all 3 equations for your board exams, because for the derivations are asked in your board exams. So kindly learn it, or I can take it in next lecture. Okay, so moving on to the next topic. What is force? What is force? So what do we mean by force? Force is when we talk about force, when we listen the word force, what comes to our mind? Pushing or pulling. This is the general thing that comes to our mind, right? Push or pull. Is this all about force? Is it all about force? Answer is a big no. Why? Because force is not all about pushing and pulling. There are various kinds of force: electric force, gravitational force, magnetic force. There are plenty of kind of forces. Okay, so how a frictional force, normal force, how are we gonna define it? Let's see. For example, this is a surface, a object you have kept. This is football, and this is at rest. Okay, so for a normal person who doesn't have any idea on physics, what will you think? Since this football is lying on the surface, it is not experiencing any force, you will see, obviously. But for you, because you have knowledge in physics, what you should think is, no, this object is experiencing forces. How is it experiencing forces, sir? First force is this. This is experiencing a gravitational force towards the earth. And the earth and the surface is also giving this object a normal force. This is also giving a normal force. And since these two forces are balancing each other in opposite direction, these forces are equal in opposite direction, this object is at rest. Okay, so for you, from now on, an object is at rest, but forces are being experienced by it. Okay, because no object on earth can be free without a gravitational force, right? So every object on earth is facing some force. Okay, this should be clear to you. Okay, another example I'll give you, explain with examples. Okay, another example I'll give you. Surface, and this is the football. Someone kicked this ball. So what happened is, it started moving. but after a few seconds, it stopped. Why did it stop? You had given a force, right? So F force is there. So it should move continuously. Why did it stop? Why did it stop? It stopped because Earth, since it is a rough surface, it is also giving an opposite and frictional force. Opposite frictional force. Okay, so because of this frictional force, the ball stopped. Because of this frictional opposite force acting on the football, the ball stopped after moving for a few seconds. You understand? So this is what is happening in physics. Okay, so after a few seconds, the ball stopped because of the frictional force acting on it. This is what is force, and this is what are the examples. Force का क्या है? Force का formula will learn in the Newton's 3 law of motion. We'll learn it there. Okay, so I'll move to the next question for today. What are the Newton's 3 laws of motion? What are Newton's 3 laws of motion? So Newton had 3 laws of motion. First, second, and third law of motion. So I'll start with the first law of motion. So what is Newton's first law of motion? Newton's first law of motion says when an object is at rest or in uniform motion, or in any direction, will continue to do so until and unless an external force is applied on it. Get it? So I'll explain it in Hindi. जब एक ऑब्जेक्ट रेस्ट में है या फिर एक ऑब्जेक्ट अगर यूनिफॉर्म मोशन में मूव कर रहा है या फिर एक डायरेक्शन में जा रहा है, it will continue to do so until and unless an external force is applied on it. Okay, this is what is Newton's first law of motion. You might be thinking this is a very simple thing. What is that to make it as a first law of motion? But at that time, I don't know why, but it has been described as one of the most greatest discoveries and Newton's first law of motion. Okay, so it has actually 3 parts. If you want to learn, first law is known as inertia of rest. Second law is known as inertia of motion. And the third part is known as inertia of direction. Okay, it has 3 parts. Inertia of rest. Inertia of rest means when the object is at rest until and unless an external force is applied, it will be at rest. When an object is at motion, it will be in motion until and unless motion. Direction, same है. इसका example भी आप समझ सकते हो. When you are sitting in a car, okay? When you, for example, when you are sitting in a car is at rest. When the car starts moving, you were at rest. When the car starts moving, what is happening is, since your lower body part is in relation, when it is in contact with the car, your lower limb is lower part of the body is in contact with the car. That is why it is moving. But your upper part of the body is at rest. It is experiencing no force. So when the car is moving, you will get a sudden backward jerk. Why are you getting the backward jerk? It is because your upper part of the body is not getting any force and it doesn't have any idea about your lower part moving. Okay, that is why it is experiencing a sudden backward jerk. Same goes for the motion. When you are in a bus, when the bus is moving in a uniform motion, when the driver suddenly applies a brake, okay, Since your lower part of the body is in contact with the bus, it will stop immediately along with the bus. Okay, but the upper part of the body doesn't have any idea. It is not getting any force. So it will continue to move in the same uniform motion. It will continue to move up forward. That is why you are getting a forward jerk. Do you understand me? This is what is Newton's first law of motion. Same about the direction also you can understand. When you're going towards left side, you'll get a right side jerk in a car or in bike also. Then comes Newton's second law of motion. What is Newton's second law of motion? Newton's second law of motion says force is directly proportional to rate of change of. I'll tell you about the formula. I'll tell you about the formula how to derive force. How to derive force in the Newton's second law. Force is directly proportional to rate of change of momentum. So how will you write it? Force is directly proportional to rate of change of momentum. Change of momentum is, we know, sir, mv minus mu. But what is rate of change of momentum? Rate of change of momentum is per second how many momentum is changing per second. By type t, how many is changing. So to remove the proportionality sign, we add proportional constant k, and it will be mv minus mu by t. So now value of k is 1. So I'm taking m common here, v minus u by t. Okay, so what will be the force formula? V minus u by t is equal to, we know it is acceleration. So force is equal to m into a. SI unit of force is Newton or kg meter per second square. Okay, this is Newton's second law of motion. What is Newton's third law of motion? Newton's third law of motion you must have heard, even if you have not studied in class 9, you must have heard it in many movies, many web series. Okay, so what is Newton's first law, third law of motion? Every object, every force has an equal and opposite reaction. Every object has an equal and opposite reaction. Every force. If we are giving this force F, the wall will also give you a force of F. That is why your what hand pains when you try to punch a wall. What happens? You are giving force to the wall. But why is your hand paining? Because the wall is also giving you a force of F into your hand. That is why your fingers pain. Okay, that is what is Newton's third law of motion. I hope it's very clear. So I'll move to the next question. What is Coulomb's law? After this, I think we have some numericals to solve. After this, we'll move to a numerical, then we'll come to theory part. Okay, Coulomb's law. So what is Coulomb's law? Have an idea about the gravitational force. How do we calculate gravitational force? It is very easy for you to learn about Coulomb's law. Coulomb's law is defined for charges. It is used to calculate electrostatic force. Okay, so how do we calculate electrostatic force and what is Coulomb's law? Let's see. For an example, this is a charge Q1, this is charge Q2. Okay, and we need to calculate what is the force acting in between these two, Q1 and Q2. What is the force acting in between these two? Okay, so what Coulomb told the force acting between two charges Q1 and Q2 will be directly proportional to Q1 into Q2. Okay, and he told F will be, and he also told F will be inversely proportional to R square. R square meaning the distance between these two is R. He told the force will be inversely proportional to the square of that distance. Okay, so to calculate force, we have to add a constant, proportionality constant K1, Q2 on R square. We added a proportionality constant called K. So what is K, guys? I think you must have heard this. You must be knowing 1 upon 4 pi epsilon. And the value of this is 9 into 10 to the power 9. Okay. And since this value is so large, the electrostatic force is very much greater than gravitational force. It's very large. This quantity is to use very large quantity. Okay. So the force of F is very large. Electrostatic force is very large. This is what is Coulomb's law. Okay. First, you know that it's directly proportional to the product of their charges, and it is inversely proportional to the square of this distance. Then you can calculate the force. This is what is Coulomb's law. Okay, guys. So moving on to the next question, I told first we will just learn some numericals, then we'll come here. Okay. I'll explain this now. First, question number 11. Two blocks. You like this question. See, guys, from the Newton's laws of motion. That is why I thought of solving it after Newton's laws of motion, after I described about Newton's laws of motion. So see this, guys. Two blocks of mass M1 and M2 are connected by a light spring on the smooth surface kept in a horizontal surface. Smooth horizontal surface. Okay. So what happened is the two masses are pulled apart. These two masses are pulled apart. This is M2. These two masses are pulled apart and then released. So what they're asking us to do, prove that the ratio of their acceleration is inversely proportional to their masses. Okay, so let's start this question. Okay, so what happened is we gave a force and then released. Okay, so when we are releasing this mass will exert some force on this mass, and M1 will exert some force on M2, and M2 will also exert some force on M1. So let us write F12. F12 is force applied by M1 on M2. Okay, then F21 is force applied by M2 on M1. Okay, so what is F12? What is F12? F12 will be force applied by M1 on M2. M1 on M2. So F12 will be M2 into acceleration of A2. Okay. You understood this? So this is, I'm taking an equation number 1. And F21, force applied by 2 on 1. How much force has been applied on M1? M1 into its acceleration A1. This is equation number 2, guys. Okay, so then by Newton's third law of motion, what do we know? From Newton's third law of motion, we know that both the force will be equal and opposite. Mane F12 will be equal to F21, but it will be opposite. That's why I'm applying a negative sign. It will be opposite. Okay, so F12 we can write it here as M2A2 is equal to M1A1. Okay, So what they have asked us to prove that the ratio of their acceleration is inversely proportional to their masses. Okay, so ratio of their acceleration of a1 upon a2 will be equal to m2 upon m1. This is what they had asked us to prove, right? Prove that the ratio of their acceleration is inversely proportional to their masses a1, inversely proportional m1, a2, m2. Okay, guys, you understood this? I'll explain it once more. See, what happened is two objects were lying down, and the spring has been attached to both the objects. So what is happening is, we pulled the spring and released. Pull the spring, then we released. Okay. So what happened is, M1 will apply some force on M2, and M2 will also apply some force on M1. So we wrote this F12, F21. But since from Newton's third law of motion, we know the force which has been applied, or which are being played here, are equal and opposite in nature. So I wrote F12 is equal to F21. Then write F12 value, write F21 value, hence the equation will come, and it is proved. Okay, easy peasy. So moving on to the next numerical for today. What is the next numerical? Yes, a body of mass 100 kg is soaring weighting machine in the lift. Okay, lift. This is a lift, and in the lift, what happened is, a mass of 100 kg has been tied up. Okay, so the lift is ascending up. The lift is ascending with an acceleration of 2.2 meter per second square. What will be the reading in the weighting machine? Okay. So while traveling in a lift, you must have felt that when you are going down, you'll feel like you are losing your weight. Okay, you are less in weight, you'll feel. But when you are going up, you'll feel you're gaining weight. And why is it happening? Because when you're moving up, your two acceleration are being added up. What are the two acceleration? The acceleration of the lift and the acceleration due to gravity are being added up. What is the acceleration due to gravity? It is 9.8 meter per second square. So how much weight will this object will be experiencing here? If the lift is moving up with 2.2 meter per second square, and we know acceleration due to gravity is 9.8 meter per second square, what will be the weight that it will be experiencing here? What will be the weight? To calculate the weight, we know m into a plus g. What is a plus g? A is the acceleration of the lift, and g is the acceleration due to gravity. Okay, so calculate it, guys. Then it's done. M is 100 kg. A is 2.2. Then G is 9.8. Okay, 9.8 plus 2.2, it will be 12. 100 into 12. So weight will be 1200 Newton. Okay, guys, see how fascinating the physics subject is. When the lift was at rest, the weighting machine will be showing 100 kg or 1000 Newton. Will be experiencing a force of 1000 Newton. Okay, but when the lift is moving up with 2.2 meter per second, the weight will be 1200 Newton, or the machine will be showing 120 kg now. Actually, the real weight of the object is 100 kg, but it is showing as 120 kg. Okay, so it might be misinterpreted. So you must have knowledge of physics to get it correct. Okay, so we'll go to the theoretical part today, where I left it. Moving to question number 8. Two numericals we solved here. Then question number 8. What is question number 8? What is the relationship between charge and electric field? What is the relationship between charge and electric field? So you must be knowing all the objects all the objects that have a charge that have a charge that produce an electric field around them. They produce an electric field around them. So how they produce electric field, that is what we need to learn. If an object is charge is Q, we learn about both, okay? The positive charge and about the negative charges. Positive charges and the negative charges. So what happens in positive charges and what happens in negative charges? So first, before explaining electric field, one more thing. Why do we learn electric field is, you must have seen now what two opposite charges attract each other, same charges repel each other. We see this, right? So where does this come from? Why is it happening so? Why the opposite charges are attracting each other and the same charges are repelling each other? Why does it happen? That is what this we can learn from electric field concept. Okay, so move to the electric field concept. If we are taking a charge plus Q, if we are taking a charge of plus Q produces an electric field, and the electric field will be away from it. Always remember, plus Q will produce an electric field which will be away from it, and minus Q will always produce an electric field which will be towards it. And all this electric field line, guys, whatever we draw, all these are just an imaginary concept. You cannot see or cannot demonstrate it in a practical life. Magnetic field, yeah, we can do, but electric field demonstration is very difficult and it's beyond our scope of our practical physics 11 12 level. It's beyond that, so it's not possible for you to demonstrate this. Magnetic field, yes, we can do. You must have seen in class 10th even. Okay, so electric field from a positive charge is away from it, okay, and for a negative charge it will be towards it. Charge and electric field, I think that's all. No, nothing else. The next question, something was that, what is the electric field when the charge is at rest? This is also a question. When the charge is at rest, will its electric field vary? It's a good question actually. Will its electric field vary when the charge is at rest? When the charge is moving, will the electric field vary? The answer to this question is, when the charge is at rest, electric field will not change. Electric field will not change. The same electric field will be produced by it. But yeah, if the charge is moving, if the charge is moving, the electric fields produced by the charge will also continue to move along with it. It will also move along with it. Okay, it will also move. And if the charge is, they have some acceleration, the electric field will also gain the same acceleration to move along with the charge. This is the concept. You should have it. You should have in your mind. Okay, guys. Charge is at rest, charge is moving, and charge when the charge is in acceleration. So we discussed this question, question number 8, the relationship between charge and electric field, how the charge differs from a positive and a negative charge, and what happens when the electric field, the charge, this is C, charge is at rest. Okay. Then we will come to what is Gauss law. So what is Gauss law? And for what the Gauss law is defined, first I'll tell for what the Gauss law is defined, how do we calculate Gauss law, and what are the different variations of Gauss law. Gauss law. So what is Gauss law? Gauss law is defined, it was defined to calculate electric flux. Calculate electric flux. It was defined to calculate what? Electric flux. Understood? So electric, it is defined to calculate electric flux for closed object. Don't forget this word. For closed object or closed space. I mean, how, for which object it was defined? If we take a sphere, okay, and a charge q is placed over here, in the center of the object, what will be the electric flux due to this object, through this surface area? What will be the electric flux? Understood? That is what is defined. That is what is Gauss law. So actually electric flux is, if you might be knowing what is electric flux, electric flux is electric field into the surface area, electric flux into surface area. But Gauss was a scientist who got an idea, who told that if you are placing a charge q in the center of an object, if you're placing a charge q in the center of an object, we need not do all this bullshit. I mean, we need not do all these things. We need to calculate electric field, then we need to calculate surface area. We need not do all this. I will give you a formula which you can apply and tell the electric flux. And he gave a formula. What was the formula given by Gauss? He told electric flux through this area will be, if the charge q is placed at its center, q upon epsilon. That's all. That is all. He told q upon epsilon will be the flux through the surface. Okay, it's not only defined for sphere. You can take an example of a cylinder. You can take an example of a cone. Whatever, if you're placing it to the center now, the flux through it will be q upon epsilon. And guys, from this concept, very nice questions is being asked in competitive exams. What they will do is, they will give you a cube, giving you just an example. You do many numericals on this, okay? Then only you'll understand. If a charge q is placed over here, they'll ask, what is the flux through this cube because of this charge q? You might be thinking, just now I told Gauss law is defined for only the charges which are placed at the center, but it has been placed at the corner. What will be the flux through it? How will you calculate this? You want this charge q to be placed at its center now. So when the charge q will be at center, if you place similar 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 7 more cubes of the similar size. One more cube here. 7 more cubes. The charge q will be at center. Okay. Then the flux through the entire surface, all these are imaginary, will be q by epsilon. Okay. And through the this cube, how much? Q by 8 epsilon. Okay. And since only how many surfaces are visible? 1, 2, 3, 4. So the flux will be 32 q by 32 epsilon. You will not understand if I just tell you all this. You need to go back and see the questions, then only you'll understand. And guys, for physics, again, I am saying learning only the concept is 5% of physics. Okay, if you are preparing for some exam like NEET or JEE, you need to have conceptual clarity. I understand that physics you should have conceptual clarity, but what is more important than this is solving questions. If you know all the concept but you are unable to solve good level questions, there is no point in learning the concepts. Okay, so first learn the concepts from here in Sathi. You can watch the concepts here, you can understand the concepts first, then go back and solve questions. How many questions you will solve per day? Try to set a target, try to solve 40 to 50 questions per day at least. Numericals, physics numericals, every day. If you're solving every day 40 to 50 questions, at the end you'll see you'll be very thorough with physics. Okay, I know physics is a little tough subject, okay, but you have to give your time, then only it will be easy for you. Okay, so I'll move to next question for today. What is explain conservation of angular momentum. Conservation of momentum, sorry. Okay, so where did this come from? Conservation of momentum means, first I'll define conservation of momentum when no external force has been applied on an object, when no external force has been applied on an object, its momentum will remain same. And you can even derive this thing. How will you derive this thing is, for what do we know from Newton's second law of motion? Force is equal to angular moment, force is equal to rate of change of momentum. Rate of change of momentum. So write it up. Force is equal to rate of change of momentum. So when no external force has been applied, that means force is equal to 0. So rate of change of momentum is 0. So what does that mean? The change of momentum is 0. This is what is conservation of momentum. Change of momentum is final momentum minus initial momentum is equal to 0. This is change of momentum, na? mv, mass into velocity. Final minus initial, final momentum minus initial momentum. So mfb, final momentum is equal to initial momentum. Easy peasy. This is nothing to mug up, guys. Just learn the concept. What is the concept here? When no external force is being applied on an object, the momentum will remain the same. This is what is conservation of momentum. Momentum is being conserved. Why is it conserved? No force is applied here. So final momentum is equal to initial momentum. Okay, same like that, we can also define conservation of angular momentum. So conservation of angular momentum is, what is conservation of angular momentum? And we also know torque is equal to change in angular momentum upon time. Change in angular momentum upon time. So when the torque applied on an object is 0, the change in angular momentum will be 0. So the final momentum, angular momentum, will be same as initial angular momentum. You learned it, right? How to derive this? How to derive this? Okay, this is what is conservation of momentum. So next question is, what is an electric dipole? What is an electric dipole? So to understand electric dipole, I'll give you an example. What is electric dipole? First I will define electric dipole, write the definition of dipole, then you'll understand. What is electric dipole? Electric dipole is, it is a system of 2-point charges which are equal in magnitude but have opposite nature and are separated by a small distance. It is a system of 2 point charges which are equal in magnitude but have opposite nature and separated by small distance. You can understand when I'll draw a diagram for you. If this is a charge plus q and this is a charge minus q, and the distance between these two is r, and this is a perpendicular line passing through these two, okay, and this is a charge plus q and this is a charge minus q. Okay, so what is electric dipole? It is a system of 2 point charges. This is a system of 2 point charges which are equal in magnitude q and q but have opposite nature, plus q minus q, opposite nature, and are separated by a small distance r. Separated by a small distance r. This is what is an electric dipole. So why is it defined for? Why do you need to understand about electric dipole? And what is the formula to calculate electric dipole? What is electric dipole moment? Formula क्या है इसका? Formula is it is the multiplication of the magnitude of one charge and distance between the charges. Okay, so कैसे इसको calculate करते हैं? Electric dipole moment P is equal to Q. It is a multiplication of magnitude of one charge Q and the distance between two charges. If the distance between those two charges is 2a, distance between two charges is 2a. P is equal to Q into 2a. This is what is electric dipole moment. Understood this? What is in dipole and what is in electric dipole moment? Okay, so here we are with our last okay, so with this I think I have covered so many questions today, and I had taken so many theoretical questions and so many numerical based questions. I hope it's very clear for you guys. Now please go back and learn the concepts and apply it in your numerical part. Okay, and only it will be crystal clear for you. Okay guys, so with this, thanks for attending the session guys, and all the best. Prepare for the best. Ta-ta.